All right, Designstream 003 with David Giesel here, and we got Corey Upton on the other side. Going to be talking about taking the Wi-Fi, the safer Wi-Fi router concept we talked about in Designstream 001 from a idea that we talked about in that design stream towards an actual product. So let me get the right screen set up. There we go. So how do you go from this thing that you want to make that you kind of have a general idea about into um, into something you can build and something that has a spec, something you can describe to your vendors and the other people working on the project. So this is the first step in that process. We're going to go through. Corey's going to take us through some of the design decisions, and then in the next or a later design stream, maybe number 4 or 5, we're going to build a specification around the more cohesive concept and work through the process that way. So Corey, do you want to show us this prototype that you've put together and tell us about it?
Yeah, so this isn't specifically part of the router, but it's something that the router could incorporate. And it's something I mentioned, I think, on the first stream, and it's a kind of a light show thing. And one of the issues with RF is it comes in really fast pulses, and it's hard to kind of, our brain doesn't work on that time scale. So this is a little Arduino. It plugs into a, let me get a picture. It plugs into the audio output of any RF meter. In this case, I'm using the Safe and Sound Pro 2. And it just listens, and it samples the audio output. And anytime it hears a click or any kind of radio signal, it lights up some LEDs that are behind a cone. And instead of just flashing to the RF, it has kind of a like a peak hold with a decay. So it lights up and then it stays lit. So one little pulse will cause it to kind of jump to life, and then over 30 seconds or so, it will decay. And so this is a time lapse of it running. So you can see I'm using my computer, and I turned the Wi-Fi on and off a couple times. And so it's going out, and then it gets a little bit of a signal, and it pops back on, and then decays out. So this is using, like I said, the Safe and Sound. So it's looking at all frequencies, broadband stuff, but it could also work on the Wi-Fi router itself, just listening to kind of the Wi-Fi. It could be a visual indication of the Wi-Fi traffic in the area.
So the reason you'd want to do this is if you're going to bed and you don't want to turn your meter on and scan your house every time when you go to bed, you could just have something like this set up where if the light is glowing, or if it's coming on and dimming out and coming on and dimming out, you still have something on. But if it's dark, that everything's off and your sleep space is RF quiet, and that you'll get a good night's sleep.
Yeah, it's kind of a cool night light, and it's quiet. A lot of times I'll just leave my Safe and Sound plugged into USB with the audio on low, and it's kind of just whatever's in the background. That can be a little annoying if you have to use your Wi-Fi for something, because it's always in the back. But at night and when everything's turned off, it's kind of interesting just to hear the RF traffic of the neighborhood, so to speak. Mm-hmm. And this lets you do it visually, so it's not this isn't something that would like wake you up if there was a big pulse or transient that came across.
Mm-hmm. Yeah, so with the lights, you were talking about how to use this with just Wi-Fi. So we see how it works, and then you're talking about using this with just Wi-Fi, like using, in the case of our router, there's built-in, any Wi-Fi radio chip has a built-in detector circuit in it to sense the signal level of the other devices connected to it. And so any router can tell how it could go into a listen-only mode where it's not transmitting, it's just listening. And it can tell on the frequency bands, the 5 gigahertz band and the 2.4 band, if there's any traffic. And then it should be able to use that signal strength to light up these lights, just like Corey was showing.
Right. So maybe at this point we can kind of jump into our router discussion.
Yeah.
And so what I have up is this is just a Raspberry Pi model. And the idea is that this bottom board represents some kind of custom PCB that allows you to interface stuff like LEDs. You'd have your power regulation on there, maybe some network stuff. And then you'd have some kind of other board, like in the Raspberry Pi. I just had a model for it, so I dropped it in. And so this just shows different configurations of how I made new parts that are not set up in all the configurations. So it could go like that, and then it could go like that. So this one I have a little case, and I put this would be like there'd be LEDs behind this, and then this would be translucent plastic, so they would kind of glow through. And then inside of that, you have a little plastic frame, and that would support some of the components inside, and everything attaches to that. So that this vertical member here would be kind of like, it's connected to the base, and that would be kind of like the backbone of the device that everything would attach to, and that shell, this shell lifts off of that.
Mm-hmm.
So kind of going back to last week's design, it's good to start, even though everything will change, it's good to start talking about mechanical stuff, even when you're doing early layout and figuring out what the device is even going to do.
And here you're designing this around a Raspberry Pi, which is a all-in-one, off-the-shelf mini computer. You can just go out and buy it. It's the green circuit board. And so the idea here is, for the prototype, we can make it without having to do any of our own circuit board design. And then if the concept works well, then we can build a more customized, cost-effective, custom design. But we're starting here by doing an exercise that would be called an MVP, or a minimum viable product, where you take stuff that's off the shelf, that's simple, that you can configure quickly, and you build around that to see if the thing is even going to work the way that you want.
Right. Yeah. So it gets you up and running without getting stuck in a perpetual cycle of what could this be eventually. And it's a good way to those things are held in tension. You release too soon and nothing really works, and you wait for everything to be perfect and nothing is ever delivered. So definitely a balance. So I'm going to jump on there.
Cool.
Yeah. So one of the ideas I had, so there's the router side, and then there's the radio side, and a lot of routers that you buy today are just wireless routers, so that it's got the antenna built in. It's all on the same board. The antennas come off. But this is a MikroTik, 4-port, 4-port router. And so this is just a router, and there's no radio on here. And I'm not sure if you can put custom firmware on this, probably not, but there are router boards like this that you can just get. And one of the things I was thinking is that would be one of the modules that just kind of plugs into the router case that we're building. And one or several supported devices, and then there would be a firmware that goes on it, and then adjacent to that would be your access point, which is the again, we talked about this in a previous video. Inside your home wireless router, there's actually a couple of things. There's a firewall, which is used to be a physical device like this that you buy. A switch, which is all the ports, and then the router, which is more of a computer device than a hardware one, and then your access point, which is the radios. So by breaking those out, we can control the radio function while not having to completely redesign a router.
Mm-hmm. And the radio can be separate. The rest of the router and the switch that you're talking about, that's what takes your local network, so what you plug into in your house, and then the router part translates all your traffic between the internet and your local network, and that's where your security and all that stuff happens. And then the wireless radio lives inside your local network, and so we could make that separate. We can have the radio be a separate piece from that. And you have in these notes, you talk about radio power control, USB power switch. So in the event that the radio is a separate device, it can be turned on and turned off without affecting the rest of your internet connection. So let's say you have a TV, you have a smart TV that connects to the internet, and you plug it in via Ethernet. Most smart TVs have a wired Ethernet jack on them, and you can wire them into your network. And your kids or your wife or whatever, your family's watching Netflix, and you want to turn off the wireless network because you're done doing whatever wireless stuff. If all those components are separate, you can turn off the wireless without affecting the rest of the internet connection. And that's what you're talking about there.
Yeah.
The other cool option of that is when we implement this device, if we use a wireless radio that's USB, just like a USB stick that plugs in, that gives you a little wireless network, we can actually leave it up to, we can sell the device with no radio. So it's really super duper safe. And then the end user, the customers, if they want, they can go and buy a Wi-Fi USB stick, and if they so choose. And that also makes it so that if you sell the device without a wireless radio in it, you don't need to put any FCC compliance marking on there, which is kind of neat. Mm-hmm. And you make that like an aftermarket option for the user.
Right. Yeah. So one of the issues with regular access points, like I should make a map, but I did in the first video. If you go check out the first video, I talk about how my home network is set up, and they're all power over Ethernet access points from TP-Link, and they take about 45 seconds to boot, even though it's just an access point. So if you want internet and you hit the internet button, or the timer turns on in the morning, you notice it more when it turns off at night and you go and turn it back on. You still got to wait for like 45 seconds to get your internet back on. And being able to use a radio that can be controlled so that the device is on and it's in a listen-only mode. There it is. In a listen-only mode, that lets you detect your surroundings, and then when ideally you would be able to turn that radio back on almost instantaneously without having to boot the device. So we would be looking for a wireless access point that we have control of the radio function without actually turning the radio off, because then you'd need two radios, one that's in listen mode and then one that you toggle the power to, which would also work.
Some of these you can see. This is the diagram of the system that Corey's talking about. Up at the top, kind of top left, you see Wi-Fi radio. You see power control right below that. That's what we're talking about right now. Some of these radios, you can just turn the transmit function off. So you can leave the radio on, and then you can just use it to listen. And that will be if we use a separate radio like a USB radio, that'll be a feature that we need to look for. And there will be certain USB radios that will work, that will provide that functionality, and some that won't.
Yeah. So going back to this design sketch I made that's up on the screen, that router control was the kind of gray board in that CAD model that I had. And then that would be that's the thing that we're talking about building, and that kind of does all this other stuff that's not really directly related to routing internet traffic, but just it's more of a radio control. And yeah.
We're making, yeah, you see router control in the center of that diagram. It's sort of like the glue. It's sort of like a wheel with spokes. And the part we're going to make is the hub. And then these spokes go out to a bunch of components that already exist. Wi-Fi radios, routers, RF detection, all this stuff already exists. We're just going to make the glue that ties it together. And then also the display and the presentation of it, the packaging of it as well.
It's like gluing your Legos together.
Yeah. Yes, only this will actually be able to be taken apart too. Like we're gonna open source the whole design so people can chew on it, take it apart.
Yeah. So one of the issues that we talked about was okay. So the use case is that your device is powered on without the wireless on, and you walk into the room and you want to use some Wi-Fi. So you turn your phone's Wi-Fi on, and it blasts Wi-Fi and looking for a hotspot, and that's supposed to wake up your router and have it turn the radio on. The issue is that, say, your neighbor in the apartment next to you has Wi-Fi on the opposite side of the wall or something like that. You need some kind of moving threshold to detect what your noise floor is. And
then so the noise floor is like the ambient level. So let's say, like in my house here, okay, there's a cell phone antenna down the way, and I have neighbors who have Wi-Fi on, and so the stuff around me means that it never gets quieter than a certain amount. It's like when you live in a city and you open the window, there's always noise coming in from the window. But if you live in the country, you open the window, there's no noise. So that minimum amount of noise that you get in your environment's the noise floor.
Yeah, and when I had that that data logger set up that just tracks RF over the day, I remember seeing that it is lower at night because people just aren't using. There's not as much network traffic from cell phones and Wi-Fi and all that stuff. So your noise floor is going to kind of shift throughout the day, shift as new network stuff comes up. So it would be kind of difficult to set a specific noise floor and just have it work in all cases. So one of the things that I wrote in the code for that the LED thing is it's a moving noise floor detection thing. So it samples and it actually takes about 2 minutes when you first plug in that LED. It's kind of like a little too active, and it takes about that long for all the samples for the noise floor to get saved in the array, because it samples every like 20 seconds or something like that. Mm-hmm. And but once it's set up with all that data, it starts behaving better, and the noise floor function starts working. So it's just looking at samples. It tries to pick out things that are not real loud, and it just kind of takes the average across time,
And so only the loud,
excluding peaks. Yeah,
yeah, only the
excluding
loud
peaks.
events happen. So this would
Yeah.
be like, as far as sleep goes, this would be like if you were asleep and you're asleep, for 8 hours or whatever, 6 hours, and every hour, every 1 hour, somebody rides by on like a really loud motorcycle, but it's only like 10 seconds per hour, right? There's 3,600 seconds in an hour. It's only loud for 10 seconds. Um, so you could say, on average, your neighborhood hasn't gotten any louder.
Hmm.
It's only loud for 10 additional seconds every 3,600 seconds. And so it's nothing, right? There's no increase in
Hmm.
the, except that you're going to wake up every hour when that thing goes by. And so that's what you're doing is you're taking that baseline and you're subtracting it out, and then you're saying when these loud events happen, um, I don't care about the average noise level. I care about the peak noise level in these small events, because those are, with sound, those are what wake you up from your hearing, and with RF, that's what disturbs your nervous system through cell membrane activation.
Right, and the sound thing is um, a good analogy because you can sleep in a noisy environment as long, like an airplane. Airplanes are really loud, but it's a constant drone of the engine, and nothing stands out from that background. So your brain automatically kind of does that noise floor calculation with sound and kind of cancels it out. I mean, to the people who can't sleep on airplanes might not agree with this, but
It's generally less disruptive than
yes,
than
yeah.
sudden loud noises like a
Right.
car backfiring or something. Yep. Yeah. Okay. Cool. So then we have. Is there anything else on router layout?
Nope, that's all.
Okay. Wi-Fi detection and radio options. So we've talked about this a little bit. You have in here, what is an SDR? So, um, interesting question. There's a thing called an SDR, which is a software-defined radio. And so this is a radio where there's like little. A radio is a lot like, most radios are a lot like a musical instrument or a tuning fork specifically. They have um, they have one frequency, like a tuning fork, or a bell choir is a great analogy actually. If you've ever seen a bell choir perform, there's all these bells for each note, and you pick up a bell and ring it and then put it down, and you pick up a bell and ring it and put it down. And a bell rings at one frequency. They're not tunable, right? If you make a bell and you strike it, it's always going to make the same note. And so most radios are built the same way. And
Unless
so,
it's the
like,
Liberty Bell.
unless it's Liberty Bell and it cracks, and then it doesn't make very good sound at all. Um, so most radios operate at one frequency primarily. They're tuned for that frequency, and they can't transmit or listen to other frequencies. They're just on this one band, um, this one frequency band. So an SDR is a thing called a software-defined radio, and what makes it special is the software part means there's code, there's a program inside of there that allows it to tune some of the circuit elements that affect the frequency that the antenna works at. And so you can take that singular frequency, the bell, and you can actually move it up in frequency or move it down in frequency, um, based on software. So you can kind of sweep, you can kind of move it around. Um, for transmitting, when you're trying to broadcast, this means that if you're in an environment where there's another um, radio on the same frequency, you don't have to compete. You can move to a frequency that's open, and you can do your transmission there. Um, for listening, um, an SDR is really cool because with an SDR, you can step it through all these different notes, basically all these different frequency bands, and you can listen. You can say, "Is there anything here? Is there anything here? Is there anything here?" And you listen to all of them, and then you know which ones are busy and which ones are quiet. And then that tells you which ones you can transmit on. For our application, um, an SDR, especially when you're asleep or you're doing this nightlight and you're not even transmitting, an SDR could be cool because it'll let you sample different parts of the frequency range. Um, that you might not normally listen to. This is a little bit the broadband RF detectors that you see out there, like the Safe and Sound meters or the EM Fields Acousticom acoustimeters, the Cornet Systems ED88T, all these. These are broadband meters, and so they listen to everything on the band all at the same time. It's a little different than an SDR because they're just hearing everything, whereas an SDR is listening to slices as it moves through.
Hmm.
The cool thing about listening to slices is that when you do find something, you know what frequency it is. When you're listening to everything, you can't isolate what frequency it is.
Right. Do we want to talk about uncertainty principle? And the analogy is with an electron, you know its position or its velocity, and here you know the frequency or the amplitude. So with the broadband detector, you're listening to everything at once, but that comes at the cost of knowing what frequency that transmission came on. And then if you're doing the sweeps, you know what frequency, but you're missing everything. You can't listen to everything outside of that frequency. And the higher the resolution of that sweep, the longer it takes to go through. So the more stuff the more pulses that you're listening to.
Yeah, yeah, exactly. When you're listening to one specific thing at a time, you're missing everything that's going on at that time.
Mm-hmm, mm-hmm.
That's the conundrum, and there's a trade-off. So there's a few different ways to do that. We've talked about that. For this device, there's a few different ways to measure frequencies specifically or specific bands and do it concurrently. Um, Basically, it just involves money. If you pour money on the problem, you can solve it. And then you
Right.
no longer have an affordable detector or
You
an
end up
affordable router.
you end up with an entire bell choir with all all the sharps and flats and semitones and but
And
it
all the
gets
people to
expensive.
swing all of them at
Yes.
once. Yep, that's right. It becomes complicated and expensive.
Right. Right.
So for this device, you have this note. What are options for listen only? Um, Well, the easiest thing to do for a Wi-Fi router here is the Wi-Fi radio, whatever it is, if it's built in, if it's USB or whatever, it will have some intrinsic built-in listen functionality that'll just be for free. It'll just be on board. So the easiest thing to do for listen only is you turn off the transmitter or you turn the transmitter power down to 0, same thing kind of, and then you just listen. And you're only going to hear what's going on in the Wi-Fi frequency bands. Um, so it's not going to tell you everything that a broadband RF detector is going to tell you. But if you already know that your space is relatively quiet, if you don't use Bluetooth, if you don't use a lot of 2.4 gig stuff that's non-Wi-Fi like Bluetooth or whatever, if you don't have a DECT phone, those cordless 900 megahertz phones, if you know that the Wi-Fi that you're using is really the only transmitter in your space, then that's really the only thing you need to listen for. And so if you have a broadband meter or if you already know your space is clean, if you've kind of scrubbed your living space, then it's not a big deal if the only detector is your router. It'll
Mhm.
only pick up the 2.4 gig, and the 5 gigahertz Wi-Fi bands, but that's probably fine. And they do sweep. Those radios can detect across some bandwidth. They can step through a few frequencies there. So it's going to catch. It's going to catch probably most of the stuff you care about, and it's free. It adds no cost to the device.
Mhm. It's
So
already there.
it's already there. So that's a really good option. And then the other option, the cool thing about what you've done, Corey, with the audio jack plugging in um, to the nightlight that you made that we saw at the beginning, is any RF detector out there, any of these broadband detectors that are out there that have a headphone jack. So like Safe and Sound Pro, the Acoustimeter, the AM10, I think the Cornet, the ED88T. And then there's a couple other ones out there too. They have headphone jack outputs. They have an audio modulated output. You take any one of those meters and plug them in, and they'll operate as a broadband RF detector for that light functionality. So
Mhm.
if you want to sense more than just the Wi-Fi, and you either have or would like to purchase a RF detector, you just plug it in, and then you got full broadband coverage.
Yeah. So in the coming weeks. Well, look, we talked about doing a design for just a standalone nightlight. So maybe that's something that we can cover in some future videos, and I might do some screen recordings of the CAD process and some stuff with 3D printing and that kind of stuff. So
For sure. Yeah, we likely will. I mean, this is another part of designing a product is if you have a big project and you can divide it into little pieces, especially if they're discrete, um, if they can stand alone as their own product, that's a really good way to kind of step into this. So
right,
yeah, that
yeah,
nightlight's something that would be really cool to do, and we might do it all in analog electronics as well.
I would learn a ton from that. I'm not I know how to do a little bit of coding and stuff, and I did it all on with an Arduino, like I said. But that'd be a really cool way to learn some analog stuff, which is pretty neat. So,
Yeah. Um, cool. Well, that wraps it up for this episode. On the next one we'll go into the next steps of this, and then we'll get into once we have the product picture solidified, we'll get into some of the details about how you make each one of the subsystems. Those will be fun videos.
yeah. All right.
Cool.
Thanks for joining us, and we'll talk to you next week.